3 hours locked in this battle of wills with an AI over just a simple, I don't know, 200-word email.
Oh, we have all been there. It is the worst.
Right. You type out your request, the cursor blinks, and then this block of text materializes, and within the very first sentence, you feel that familiar knot of frustration.
Because it's completely sterile.
Exactly. It sounds like a corporate brochure written by a committee of robots. So you hit backspace, you delete the whole thing.
You burn it down and start over.
Yeah, you type a new, even longer paragraph. You're throwing in more adjectives, capital letters, exclamation points, basically pleading with the machine to just sound human.
And then what happens?
Then you hit generate, and it sounds like an over-caffeinated infomercial host.
Yeah, you went from robot to a cheesy late-night ad.
Right. And you're treating the AI like this stubborn human employee who just refuses to listen. But the reality is you should be treating it like an engine.
That is exactly the shift we need to talk about.
So today we are doing a deep dive into the materials from AI Prompt Lab's APL 102 module. And our entire mission, the whole goal here, is to destroy this habit of blind rewriting.
Yes. Treating the chat interface like a text message thread with a human is really the original sin of prompt engineering.
Oh, that's a great way to put it.
I mean, a human reader uses lived experience, right?
Yeah.
They use social cues, common sense, to kind of fill in the gaps of your poorly constructed instructions.
Right. If I tell you to write something better, you sort of intuitively know what I mean based on context.
Exactly. But a large language model, an LLM, does not have common sense. It has an attention mechanism and a probability distribution model.
Which is very different.
Completely different.
Well,
So when you get a terrible output
Yeah.
and react emotionally by just, torching the entire prompt and starting over, you're engaging in what we call prompt chaos.
Prompt chaos.
Yeah. You
Yeah.
change the tone, you add 5 new rules, you redefine the task all at once.
Just throwing spaghetti at the wall.
Right. And if the output miraculously improves, you learn absolutely nothing. You have no idea which of the 10 levers you just pulled actually fixed the problem.
You're just playing a slot machine.
A slot machine with your workflow. Exactly.
I really want to build on that engine analogy because I think it fundamentally changes the mental model for anyone listening.
It's crucial.
Think about walking out to your driveway in the morning. You turn the key in the ignition and your car just doesn't start.
Right.
Your immediate reaction isn't to call a tow truck, send the car to a scrapyard, and go buy a new vehicle.
That would be insane.
Right. You pop the hood, you look at the modular systems, you check the battery terminals for corrosion, you check the spark plugs.
You listen to the starter motor.
Exactly. You isolate the failure to a specific component. Well, a prompt is exactly that. It's a mechanical system composed of distinct load-bearing layers.
And this is where people get confused about prompt length.
Oh, yeah, like, my prompt is huge, why isn't it working?
Exactly.
Yeah.
A prompt can be 4 pages long and still fail catastrophically if it's missing the spark plugs.
Length is not a proxy for structural integrity.
Say that again because people really need to hear it.
Yeah.
Length alone does not equal a good prompt.
People assume that, like, feeding the LLM an overwhelming volume of words will just act as a substitute for precision.
The brain dump approach.
Brain dump. But an LLM processes text through self-attention layers. Every token, every chunk of a word has to mathematically weigh its relevance against every other token in your prompt.
Right. So when you dump 1,000 unstructured words into the context window, you're just forcing the attention mechanism to distribute its focus across this massive flat hierarchy.
You dilute the whole thing. You dilute the importance of your core instruction.
You really do. And to move away from this guessing game, we have to transition into the role of a diagnostician.
And that's what APL 102 is all about, right? It breaks this diagnostic framework down into 8 specific prompt anatomy layers.
8 layers. And we should probably dive straight into the first cluster of those layers, which really acts as the foundational mechanics of the prompt.
The engine block.
The engine block. I like that. So this consists of 3 things: the task, the context, and the input data.
But wait, before we define those, we need to address the absolute most common beginner mistake highlighted in the module materials.
The blur.
The blur, yes.
Oh, it's everywhere.
Users tend to just dump their goal, their background information, their raw materials into one massive paragraph, label the whole mess context, and just expect the AI to sort it out.
And it is disastrous from a technical standpoint.
Why? I mean, it feels natural to just talk to it that way.
Well, let's look at how autoregressive models actually work. They predict the next token based on the sequence of tokens that came before it.
Okay.
So when you blur the instruction, the background, and the source material all together, The model has to simultaneously infer what the verb is, what the setting is, and what the payload is.
It's trying to do too many things at once.
It has to guess the hierarchy of your text. And when an LLM is forced to guess, it defaults to the densest, most generic clusters in its training data.
It just takes the path of least mathematical resistance.
Exactly. But by separating task, context, and input data into distinct labeled sections, you are providing the attention mechanism with structural scaffolding.
You're literally telling the model, this section is the operation to perform, this section is the environment, this section is the raw material.
Right, it takes the guesswork out entirely.
Let's dissect the task layer first then. This is the core instruction, the action.
The verb.
The materials really emphasize the absolute necessity of using clear, unambiguous action verbs like summarize, extract, diagnose, synthesize.
Because precision matters.
But I see people constantly using incredibly weak verbs. They say, help me with this proposal, or look at these notes, or my favorite, make this sound better.
Help me is an interactive plea. It's not a computational directive.
Right. The machine doesn't feel pity for you.
No, it doesn't. And if your task is make this better, you are opening up an infinite probability space.
What does better even mean?
Exactly. In a vector space, what does better mean? Does it mean correcting the syntax? Does it mean altering the persuasive framework?
Or does it mean expanding a bulleted list into a whole narrative?
The AI will just pick one of those paths at random, based on whatever subtle linguistic triggers happen to exist in your raw text.
The task is the steering wheel.
It is the steering wheel.
Yeah.
If you want the model to isolate specific arguments from a transcript, the verb is extract.
Right.
If you wanted to combine 3 different documents into a cohesive summary, the verb is synthesize.
So the precision of the verb narrows the probability distribution. It forces the model to access the specific neural pathways associated with that cognitive operation.
You're telling it exactly which part of its brain to use.
Okay, so that leads naturally into the context layer. If the task tells the engine what to do, the context tells the engine where it's operating.
The frame of reference.
Right. The APL 102 module stresses that context anchors the output to a reality.
Give me an example.
So write a lesson is a task operating in a total vacuum, but this output will be used as a beginner module in the AI prompt lab community for users who are intimidated by code.
Now that is a fully realized context.
Exactly.
Because context acts as a high-level filter on the token prediction process. Let's say your task is to write an email about time management.
Okay.
Without context, the LLM will draw from the absolute center of its time management training data. You'll get a Wikipedia-style encyclopedia entry about the Pomodoro technique.
Boring and completely useless.
Technically accurate, but yeah, entirely useless. But when you provide context like, this email is being sent to exhausted freelance graphic designers who are dealing with scope creep from demanding clients.
Oh, wow. You drastically shift the vector space.
Completely. The model now pulls vocabulary, tone, and framing from texts associated with freelance burnout, client negotiation, creative fatigue.
The context defines the stakes of the output.
It tells it why this matters.
Okay, now let's talk about the input data, or the source material. This is the actual payload, right? The transcript, the rough notes, the customer feedback.
The raw material it's processing.
But I have to play devil's advocate here for a second, because splitting the input data away from the task and context feels, I don't know, incredibly rigid.
It feels formal.
Yeah. When I'm working quickly, it feels so much more intuitive to just type, hey, can you summarize this article I read about data privacy and highlight the European regulations? And then I just paste the article.
Right, yeah.
It uses fewer tokens. It feels conversational. So why is it computationally dangerous to embed the input data directly inside the conversational instruction?
It really comes down to a phenomenon known as instruction hijacking, or sometimes it's called attention dilution.
Instruction hijacking.
Okay, when you paste raw source material directly into the same block of text as your instruction, you're introducing foreign variables into the AI's instruction following hierarchy.
Wait, break that down for me.
Imagine pasting a client email into your prompt. The client's email contains questions, demands, and imperatives. Like the client says, please reply to this urgently, or make sure you include the budget.
Oh, I see.
If you haven't explicitly fenced off that text as input data, the LLM's self-attention mechanism might latch onto the client's instructions instead of your instructions.
Because it can't intuitively distinguish between the prompt I wrote and the text I pasted. It's all just tokens to the model.
Exactly. It's all just one big blur. By creating a distinct input data layer, ideally using markdown fences or XML tags, you quarantine the payload.
You're telling the model, do not obey the text inside this box, only process it according to the task layer.
Quarantine is the perfect word for it.
I've actually watched that happen in real time,
Oh, really?
Yeah. I pasted a long interview transcript into a prompt and asked for a social media hook. And the interviewee in the transcript happened to say, the most important thing you can do is write a 5-page business plan.
Oh, no.
Yeah.
Let me guess.
The AI completely ignored my request for a social media hook and instead output a 5-page business plan.
Yep.
Because it latched onto the command buried inside the transcript. It totally lost the plot in the blur.
That is a textbook example of an attention failure caused by a missing input data boundary. The model weighted the imperative in the transcript higher than your initial instruction.
So how do we fix it?
A structurally sound prompt separates them perfectly. Task: extract 3 counterintuitive quotes for a social media hook. Context, as for a LinkedIn audience of startup founders. Input data, and then you enclose the transcript in brackets or tags.
The separation removes the ambiguity.
Entirely.
Okay, so the engine block, task, context, input data that handles the raw processing. The AI knows what operation to perform, the environment it operates within, and the specific payload it has to process.
The core mechanics.
Right. But knowing the answer and communicating the answer effectively are two very different disciplines.
Very different.
Which brings us to the next structural cluster, the interface and the boundaries.
The engine does the intellectual heavy lifting, but the interface dictates the delivery mechanism.
And if we don't define the interface, what happens?
The LLM will just fall back on its default persona, which is designed to be as harmless, helpful, and bland as possible.
The generic AI voice we all hate.
Exactly.
So the interface encompasses audience, role, and style. Let's tackle a massive trap right out of the gate here. The module materials point out that users constantly use single adjectives as a lazy substitute for a fully developed interface.
The worst offender.
The most notorious one is the word professional.
Oh, yeah.
People just type, make it professional and consider their job done.
And it never works. Because professional is a subjective, contextual human concept that translates terribly to an LLM's latent space.
How does the AI interpret it then?
When you instruct an LLM to be professional, you have to consider what text in its training data is tagged with that concept.
Right. What did it read that was labeled professional?
Exactly. The model pulls from corporate liability statements, human resources reprimands, and user license agreements.
Oh, gross.
Right. It defaults to this sterile, passive voice corporate speak that actively repels human attention. A bank's privacy policy is technically professional, but you would never want your newsletter written in that voice.
That explains so much. That's why every time someone asks for a professional LinkedIn post, the AI spits out sentences like, in today's ever-evolving digital landscape, it is imperative to leverage synergistic paradigms.
It is imitating the worst habits of corporate bureaucracy.
So to fix this, the APL framework requires us to separate audience, role, and style. Starting with the audience layer, who is the final consumer of this output?
And this isn't just about demographics, right? It controls fundamental linguistic dials.
What do you mean by dials?
Defining the audience dictates the assumed knowledge base, the vocabulary complexity, and the pacing of the output.
Give me an example of how that changes things.
Okay, if you define the audience as beginner AI prompt lab members who have only used ChatGPT for writing grocery lists, the LLM will automatically unpack acronyms. It'll avoid dense technical jargon, and it'll use highly relatable everyday metaphors.
Because it knows they need that scaffolding.
Exactly. But if you shift the audience to, say, senior machine learning engineers analyzing parameter efficiency, the model bypasses all the introductory concepts entirely and operates at a high level of abstraction.
So if the audience layer is just missing,
The LLM tries to speak to everyone simultaneously, which results in text that over-explains the obvious while completely glossing over the nuance.
it's writing for no one.
Exactly.
Okay, then we add the role layer. So if the audience is who the AI is speaking to, the role is who the AI is pretending to be.
The posture.
The posture and the authority of the output.
And role activation is truly one of the most powerful levers in prompt engineering. When you assign a role like act as a cynical veteran investigative journalist or act as a patient methodical curriculum designer,
You're forcing the model to access a highly specific subsection of its neural network.
yes, it adopts the structural habits of that profession. A curriculum designer structures information chronologically with clear learning objectives.
And the journalist.
An investigative journalist structures information with a bold lead and heavy evidentiary support. Without a role, the output lacks a distinct point of view. It just reads like a machine generated it.
Okay, and finally, in this cluster, the style layer. This is how the output should feel. And the APL 102 materials provide this list of dangerous style words that really just need to be retired.
Oh, the subjective trap words.
Yes, words like engaging, premium, bold, warm, strategic.
They are completely subjective.
So how does the framework handle style without falling back on these generic adjectives? What do we do instead?
You transition from prescribing adjectives to prescribing behaviors.
Prescribing behavior.
Right. An LLM cannot interpret premium. It doesn't know what premium feels like, but it can execute behavioral constraints.
So what does that look like in a prompt?
Instead of saying, make the style premium, the instruction should be, use a direct, declarative sentence structure, eliminate all adverbs, do not use rhetorical questions, avoid motivational filler and industry buzzwords.
Ah, you're giving the engine concrete stylistic parameters rather than vague emotional targets.
Exactly. You give it rules it can actually follow.
This actually brings us to a phenomenon the materials describe so brilliantly, the tiny betrayal.
Oh, the tiny betrayal. So imagine you've built this flawless engine. The task is precise, the context is deep, the input data is cleanly formatted, and your interface is dialed in with a specific role and behavioral style.
Sounds perfect so far.
You hit generate. The AI processes the logic perfectly. It nails the tone, but the output arrives in a completely unusable shape.
It always happens.
You ask for a quick reference guide and it gives you a 5-page unbroken wall of text.
Yeah.
Or you ask for a social media caption and it outputs a markdown table with headers and bullet points.
The tiny betrayal. The model did all the intellectual work, but it completely failed the usability test. And now you're forced to spend 20 minutes manually squeaking the text, reformatting it, breaking up paragraphs, fixing the structure.
And this failure occurs because the prompt was missing the boundary layers.
Constraints and output format.
Yes.
The analogy I always use for this is ordering a custom wedding cake.
I love this analogy.
So you find a master baker, you define the task, bake a cake, you provide the context. It's for a wedding with 200 guests. You provide the input data, specific flavors, dietary restrictions.
And the style. Elegant, minimalist.
Right. The baker executes flawlessly. The flavors are spectacular. The ingredients are premium. But the baker delivers the wedding cake to your reception inside an industrial blender.
Technically, it's the exact cake you ordered.
All the intellectual and creative work is there, but the format is a disaster. You cannot serve a cake out of a blender.
You'd have to scoop it out, try to reshape it.
And you end up covered in frosting, doing manual labor that defeats the whole purpose of hiring a baker in the first place.
Exactly. Constraints and output format prevent the AI from delivering your cake in a blender.
It's a phenomenal visualization of the problem. Users constantly focus on what the AI should create, but they neglect to define the shape of the container and the rules of the road.
So let's examine the constraints layer first. Constraints really act as the immune system of your prompt.
The immune system.
They are the rules regarding what must happen, and crucially, what must absolutely not happen.
The negative constraints, the do-nots, seem to be the most critical part of this layer in the materials. But why is it so important to tell the AI what to avoid? Doesn't the model inherently know not to just make things up?
No, it absolutely does not.
Really?
LLMs are built to complete patterns. They have an innate bias toward helpfulness and fluency, even at the expense of factual accuracy.
So they'd rather sound good than be right.
Basically, yes. If you ask an LLM to draft a case study email based on, say, sparse input data, it will recognize the structural pattern of a case study.
It knows what a case study is supposed to look like.
Right. It knows case studies usually contain specific metrics and customer quotes. So to complete the pattern, it will simply invent a customer named John Smith who saw a 300% increase in revenue.
It hallucinates proof just to satisfy the structural expectation.
Yes.
That is terrifying for anyone using AI for client-facing assets.
Exactly. And this is why negative constraints are non-negotiable. A strong constraint builds an electric fence around the output.
Like, do not invent metrics, testimonials, or client outcomes.
Do not use hyperbolic marketing language. Do not introduce concepts not present in the input data. You have to explicitly shut down the model's natural inclination to hallucinate filler.
But let me challenge this for a second. If I stack 20 negative constraints into my prompt, do not do this, avoid that, never use this word, doesn't that dilute the attention mechanism we talked about earlier? Doesn't the AI get so bogged down in the rules that it forgets the main task?
Yep. Yeah, is a very legitimate concern. It's often referred to as the lost in the middle phenomenon.
Lost in the middle.
LLMs tend to pay the most attention to the very beginning and the very end of a prompt. If you bury a massive list of negative constraints right in the middle of a dense paragraph, the AI will likely ignore them.
So what's the solution?
Formatting and positioning. Constraints should be a bulleted list, clearly labeled constraints, and placed toward the end of the prompt, right before the output format.
Ah, so that leverages the model's recency bias.
Exactly. Ensuring the rules are fresh in its attention mechanism right before it actually begins generating text.
Which perfectly sets up layer 7, output format. The APL 102 module is very clear that format is distinct from style.
Very distinct. Style is the behavioral tone. Format is the architectural blueprint. It dictates the exact structural shape the output must take.
So a weak format instruction is simply naming the asset, like return a newsletter.
Right, that's weak. A robust format instruction provides the actual scaffolding.
What does that look like?
It looks like. Return the output in Markdown format. Use an H1 for the subject line. Use an H2 for the hook. Provide 3 bullet points for the core argument. End with a bolded call to action.
Wow, very specific.
When you define the format with this level of structural rigidity, you eliminate the cognitive load on the AI regarding how to present the information.
It doesn't have to think about design.
Exactly.
Yeah.
It simply pours the processed logic into the molds you built. No more cake in a blender.
Okay, so we've built this massive, comprehensive system. The engine processes the payload, the interface dials in the persona and behavior, the boundaries build the fences and the molds.
7 incredibly strong layers.
But there is an 8th layer,
The calibration layer.
which consists of examples and success criteria. Why do we need a calibration layer if the first 7 layers are perfectly defined?
Because language is inherently subjective, and human beings are prone to judging text based on an entirely unquantifiable metric. Vibes.
Nice, yes.
You read the generated output, and it followed your constraints. It adopted the right role. It used the right format.
But you sit back, cross your arms, and think, I just don't like it. It feels a little off. It feels too AI.
You're doing a vibe check.
I am guilty of the vibe check on a daily basis.
We all are. But diagnosing a prompt based on vibes is impossible. You cannot instruct an LLM to make it vibe better.
It doesn't know what that means.
The machine does not have a neural pathway for your personal aesthetic intuition. If you never explicitly defined what a successful output looks like, you have no objective baseline for critique.
You're just demanding the machine read your mind.
Exactly. Layer 8 replaces the vibe check with a concrete pass-fail standard.
Let's break down success criteria first. This is essentially building a diagnostic checklist for the output.
Right.
The materials suggest asking questions like, what must this output accomplish to be usable? What specific elements would trigger an immediate rejection?
Imagine writing a prompt for a community lesson. Your success criteria shouldn't just be, the lesson is good.
Because what is good?
Right. The success criteria should be, the lesson must isolate one singular failure pattern. It must introduce one core concept to solve it. It must provide a tangible, real-world example. It must end with an actionable step that takes less than 5 minutes to complete.
So clear. Now, when the output is generated, you don't judge the vibe. You audit the text against the criteria.
Did it isolate one failure pattern? Yes. Did it introduce one concept? Yes.
Did it end with a 5-minute action step? No, it asked the user to restructure their entire business model.
Boom. You have isolated the failure.
The AI failed the action step criteria. Now you can revise the prompt specifically to constrain the scope of the action step rather than rewriting the entire prompt because the lesson felt overwhelming.
Exactly. You fix the one thing that broke, and the other half of the calibration layer is examples, often referred to in engineering as few-shot prompting.
Providing a single high-quality example of what you want.
It drastically reduces the error rate. It shifts the entire probability distribution of the model toward the specific linguistic patterns in your example.
But the APL materials issue a critical warning here.
Yes, they do. LLMs are aggressive pattern matchers.
Meaning?
If you provide an example of a weekly newsletter about SEO and ask the AI to write a new newsletter about email marketing, the AI might accidentally start incorporating SEO concepts into your email marketing draft.
It copied the topical content of the example, not just the structural pattern.
Exactly. So you have to explicitly instruct the AI on how to utilize the example.
Like, review the provided example for sentence length, paragraph structure, and tone. Do not copy the subject matter or specific claims of the example.
You have to draw a boundary around the mimicry.
Precisely. So that is the complete anatomy. 8 layers: task, context, input data, audience, role, style, constraints, output format, and examples and success criteria.
It's a lot, but understanding the theory is vital.
But the true value of APL 102 lies in the application, right? It's about building the muscle memory to tear down failing prompts.
Let's do a teardown, a massive deep dive teardown.
Let's do it. This is where the rubber meets the road. We are going to simulate the exact workflow of a user experiencing prompt chaos and then apply the diagnostic framework.
Let's take a painfully common, weak prompt from the module.
Okay, the prompt is simply, write a good email about my new AI course.
It is the quintessential lazy prompt,
It takes 3 seconds to write.
and it guarantees 30 minutes of manual revision.
Let's run this through the LLM. With a prompt this sparse, the model relies entirely on the densest clusters of marketing data in its training set.
Let's guess the output.
Oh, I know exactly what it says. Subject: unlock the power of AI. Dear name. In today's fast-paced, ever-evolving digital landscape, staying ahead of the curve is paramount. Are you ready to elevate your workflow and leverage synergistic AI paradigms?
We are thrilled to announce our revolutionary new AI course.
It is excruciating. It's full of words like delve, unlock, and landscape.
It is pure algorithmic sludge. Now, the typical user reaction here is to fixate on the tone.
They look at that output and think, I need to fix the style.
All right, so they write iteration 2. Write a good email about my new AI course, but make it sound fun and human, not like a corporate robot.
And what happens? The LLM processes fun and human and outputs. Hey, friend. Wow, things are moving crazy fast out there, right? You totally need to check out this awesome new AI course I just launched. It's going to blow your mind and supercharge your business.
You haven't solved the problem at all.
You just shifted from sterile corporate sludge to hyperactive influencer sludge.
Because the user diagnosed the wrong symptom. They tried to fix the interface before they built the engine.
Let's run the actual APL 102 teardown on the original prompt. Write a good email about my new AI course. We map the anatomy.
Let's go through the layers. Task.
Present, but weak. Write a good email.
Context.
Missing. We don't know the business situation.
Orients.
Missing. Is this for cold leads or past buyers?
Input data.
Completely missing. The AI literally knows nothing about the course.
Role and style.
Weak. Just good. Constraints. Singing.
Output format.
Weak. Just email.
Success criteria.
Missing.
When you look at that diagnosis, the root cause of the hallucinated generic sludge becomes glaringly obvious.
The AI is inventing marketing jargon because it lacks input data. It lacks the payload. It doesn't know the name of the course, what it teaches, or who it's for.
It is operating in a void.
And the diagnostic rule is absolute. Identify the weakest foundational layer and fix that first.
Yes. Before we touch the style, before we add constraints, we must apply the engine.
So revision target 1 is providing context, audience, and input data.
And let's build iteration 3.
Okay. Task: draft a promotional email. Context: this is the final email in a 3-day launch sequence. Audience: freelance copywriters who are afraid AI will replace them. Input data: the course is called AI for Wordsmiths. It teaches how to use LLMs as research assistants, not writers. The core promise is saving 10 hours a week on outlining.
Look at how much we have narrowed the probability space.
Run that through the model.
The AI now knows the stakes, the target fears, and the specific product details. It won't talk about synergistic paradigms anymore. It will talk about saving time on outlining.
However, without the boundary layers, what will the output physically look like?
Because we didn't specify an output format or constraints, it will probably write a massive 800-word essay.
It'll include a lengthy introduction, 5 bullet points explaining the history of AI, a fabricated testimonial from a copywriter named Sarah, and an aggressive call to action.
It's better, but it is still a cake in a blender.
We are still scooping it out. We solved the hallucination of the core concept, but we introduced a formatting failure and a factual hallucination with the fake testimonial.
So we map the anatomy again. The engine is strong, but constraints are missing and format is weak. That is our next revision target. We apply the fences.
Iteration 4. We keep the engine. We add constraints. Do not use hyperbole. Do not invent testimonials. Keep the tone urgent but grounded. Do not exceed 300 words. And we add output format. Structure the email with a short hook addressing the fear of replacement, 1 paragraph explaining the research assistant concept, 3 short bullet points on time saving, and a single link to enroll.
Now you have a highly engineered deterministic system. The engine processes the specific payload for the specific audience. The boundaries restrict the length, prevent the hallucinations, and force a scannable structure.
You have moved from playing a slot machine to operating a control panel.
This is controlled, intentional revision. You isolated a symptom, identified the missing anatomical layer causing that symptom, and revised one specific variable.
But this systematic approach requires discipline. It is so tempting to just throw 20 new instructions into the chat window when you get frustrated.
Oh, absolutely.
How does APL 102 structure this implementation so users actually build the habit?
The module introduces a physical tool called the prompt anatomy map. It is a diagnostic worksheet. It forces you to slow down the cognitive process.
So when an output fails, you don't just touch the keyboard.
You don't. You pull up the map, you paste your failing prompt into it, you manually go through the 8 layers: task, context, input data, audience, role, style, constraints, format, criteria, and you label the status of each.
Present, weak, missing, or unclear.
Exactly. It is literally a diagnostic chart for a patient.
You write down the main output symptom. The AI keeps inventing features my product doesn't have. You look at your map, and you see that your input data is labeled weak, and your constraints are missing.
The map connects the symptom to the cause mathematically, and it requires you to declare your first revision target.
You must choose one layer to fix before you generate again.
This isolates the variables.
Yeah.
To support this, the materials also provide the Prompt Anatomy Auditor GPT.
I want to spend a minute on the Auditor GPT because there is a massive caveat here regarding how to interact with it.
Yes, there is.
The temptation is to just paste your bad prompt into the auditor and say, fix this for me.
If you do that, you have learned nothing. You have outsourced the critical thinking. The Auditor GPT is designed to be a co-pilot, a second set of eyes on your engineering work.
You feed the auditor your completed map. You say, here is my original prompt. Here are the layer statuses I identified. Here is my diagnosis of the weakest layer. Does my logic hold up? Am I targeting the correct layer to fix this specific symptom?
The GPT validates your diagnostic logic. It does not do the diagnosis for you.
It's the difference between asking a senior engineer to review your schematic versus asking them to just build the machine for you while you go get coffee.
That's a perfect way to look at it. The value of APL 102 is the internal rewiring of your own brain.
You have to learn the anatomy yourself because this is the foundational prerequisite for the next stage of the curriculum. The materials briefly tee up APL 104, which is the revision ladder.
And you cannot climb the revision ladder. You cannot systematically improve a prompt over time if you do not understand the underlying anatomy of the components you're adjusting.
It all comes back to reclaiming your time in agency. Every time you manually rewrite a paragraph because the AI sounded too corporate, or every time you delete a table because you didn't want a table, you are bleeding time.
A poorly constructed prompt is not a time saver. It is a time debt generator.
By mastering these 8 layers, you build prompts that execute predictably. You build assets.
We have covered an immense amount of architectural theory today.
We really have. We dismantled the blur. We separated the task, the context, and the quarantined input data.
We explored how audience, role, and behavioral style map to the latent space to create the interface.
We built the fences using negative constraints and rigid output formats to stop those tiny betrayals.
And we implemented the calibration checklist to eliminate the subjective vibe check.
It is a complete paradigm shift from user to engineer.
It really is.
So, if you are listening to this, we need an immediate practical application for you. Here is your action step for this deep dive.
Do not open a new chat window.
No. Open your prompt anatomy map. Find one prompt in your current workflow that consistently annoys you. The prompt that works sometimes, but randomly drifts off course. The prompt that always requires 10 minutes of manual formatting cleanup.
Paste it into the map. Systematically mark each of the 8 layers.
Identify the specific symptom that causes you frustration, trace it back to a missing or weak layer, and declare your single revision target. Fix that one layer and run it again. Experience the control of a targeted diagnosis.
Stop guessing. Start diagnosing.
And as you map that prompt, I want to leave you with a final thought to analyze. Look closely at the manual labor you perform after the AI generates its output. What specific edits are you making every single time?
Are you constantly softening the aggressive sales tone? Are you endlessly deleting introductory paragraphs that start with "in conclusion"?
That manual labor is a glaring spotlight on your prompt's broken anatomy. Which missing layer have you been subconsciously acting as a human patch for?
Identify the broken spark plug you have been compensating for by pushing the car yourself.
Replace the plug, secure the layers, and let the engine finally carry the weight it was designed to pull.